And we are back, and let's go ahead and talk about our next material, and we'll keep adding to our little or not our little, our our diagram. So now we're dealing with body-centered cubic. So body-centered cubic looks like so. We still have the 8 atoms here on the corners, but now we have a central atom. So let's answer some of the questions. What are the total number of atoms? Well, we're still cubic, so we have an eighth, an eighth, an eighth, an eighth, an eighth, an eighth, an eighth. But now we have an atom in the center that's not shared with anyone, so we have 2 atoms. Our nearest neighbor distance is still 2r. Our number of nearest neighbors, for BCC in the central atom, if you draw the 1, 1, 1 direction, all of these atoms here are touching. So it's touching here, 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 here. So we have 8 number of nearest neighbors. Now, what's the next nearest neighbor distance? So the next nearest neighbor distance is going to be A, which is our lattice parameter. And our lattice parameter here we can actually calculate. So we have basically this triangle here. So we have a triangle that looks like this. So we said that this is touching and this is touching. So that is going to be a distance of what? 2r plus 2r, so that's 4r. This is a, and we know this is a square root of 2. So again, just because of the diagonal nature, a. So we can find that a is going to be equal to 4r over square root of 3. So we could find essentially that value and actually solve for that metric. So there we go. So what else do we have? So that's a. So that's also a here. A is 4r divided by square root of 3. What are our closed pack directions? And closed pack planes we haven't touched on yet. Closed pack directions, well, if I go all the way through here, so the closed pack directions will be 1, 1, 1. Like just go through atoms. Now, what about our atomic packing factor? Well, let's go ahead and find our handy dandy mathematical notebook. So A, B, C, C equals 4 times r divided by square root of 3. Not 4, 3. So we can copy this here to get the atomic packing factor. We just submit now 2 atoms, and we have BCC, or ABCC. And 0.68, that's not the magic number yet, so we're not at 0.74. So we're not a closed pack structure. That actually makes sense because BCC is notoriously a very, shall we say, brittle structure. So especially, basically, you have in steel, you have ferrite, and you have two predominant forms of steel. Well, there's actually quite a few different forms of steel, but ferritic steel is actually one of the is typically a BCC structure, and it is much more brittle than austenite. So that is kind of the difference in those materials. So austenite is much more ductile. So we'll see you all in the next video. Thanks. Bye.